the 29th of October 2025, 11:47 p.m. UTC. Something impossible just happened in space. 3. Atlas. The comet crossed an invisible threshold today. Our Sunday closest approach, 203 million kilometers. But here is what makes today different. Everything we calculated was wrong. An acceleration appeared. Not predicted, not explained by gravity. Researchers at NASA's Jet Propulsion Laboratory detected a deviation of 4 arcseconds. 4. That number seems small, until you understand what it means. Davide Farnocchia is a navigation engineer. He received his PhD in mathematics from Galileo Galilei School. His specialty? Predicting where objects move in space. He filed the report yesterday. The comet moved 4 arcseconds away from where physics said it must be. Let that sink in. If this acceleration came from cometary outgassing, then 3I Atlas lost something enormous. Dr. Avi Loeb from Harvard calculated the numbers. Momentum conservation does not lie. The nucleus shed at least 1/6 of its total mass. 1/6. In a single month near perihelion. 33 billion tons. Let that sink in. That is 5,000 Great Pyramids of Giza, or the entire mass of Mount Everest. This number shatters every model we have. Here is the problem. Scientists cannot find the gas cloud. Where are the 33 billion tons? If the comet ejected this much material, we should see it. A massive plume surrounding the nucleus. Visible to our telescopes. Detectable by spectroscopy. We do not see it. This creates a fork in the road. Either the comet lost less mass than calculations demand, or something else is pushing this object. Something we have never seen before near a comet. Now this is where it gets interesting. Dr. Loeb suggested something that made the astronomy community pause. His words were careful, scientific, but the implication hung in the air. If no gas cloud appears by December, then cometary evaporation is not the answer. He said this: a spacecraft with a propulsion system could show non-gravitational acceleration without cometary evaporation. The timing is remarkable. October 28 exactly. NASA had gone silent. A government shutdown prevented data sharing from NASA missions. The Mars Reconnaissance Orbiter captured images on October 2 and 3. The HiRISE camera achieved 30 kilometers per pixel resolution, 3 times better than Hubble. But those images remained locked away for 4 weeks. Dr. Loeb mentioned this on a podcast. He suggested it was terrestrial stupidity, not extraterrestrial intelligence. The government shutdown delayed critical science. But a question hung in the scientific community. Why would a breakdown in government allow a technology question to remain unanswered? Think about this. The data exists. Scientists need it. The delay serves no scientific purpose, yet it happened. Here is what scientists know from the images that were released. The comet came within 30 million kilometers of Mars. The ExoMars Trace Gas Orbiter captured faint images. The comet appeared as a white dot. A challenging observation. The cameras designed for Mars are 10,000 to 100,000 times more sensitive than what this object requires. Yet, they succeeded. They saw something moving through space. Something that should not be there. Something that did not follow the rules. The James Webb Space Telescope observed 3I Atlas in August. SPHERIC's orbiter collected data the same month. Both instruments detected molecules being released. Carbon dioxide, carbon monoxide, carbonyl sulfide, water ice. But the carbon dioxide levels shocked researchers. The comet is extremely enriched in carbon dioxide, not slightly, Extremely. A study posted to RxEv on October 31 revealed the reason billions of years in space transformed this object. Cosmic rays bombarded the nucleus. High-energy particles from outside our solar system struck carbon monoxide molecules. The reaction converted them. CO became CO2, slowly, inevitably, over 7 billion years. The comet is older than our entire solar system. Our sun is 4.6 billion years old. This object is between 3 and 11 billion years old. One study suggests it is 3 billion years older than Earth itself. Let that sink in. Romain Maggiolo is a research scientist. Royal Belgian Institute for Space Aeronomy. He led the radiation study. He stated, "It is very slow, but over billions of years, it is a very strong effect." The cosmic ray bombardment altered the physical state of the ice, down to a depth of 50 to 65 feet, 15 to 20 meters. An irradiated crust formed around the pristine nucleus. Here is the problem. This crust is not original material. It is not representative of the star system where 3I Atlas formed. It is a product of the interstellar journey, transformed, aged, weathered by radiation. Scientists called this a paradigm shift. Objects like 3I Atlas are not pristine. They are galactic, cosmic ray processed. The outside tells us nothing about the inside, about where they came from, about their original composition. But something else happened at perihelion. The comet grew brighter, unexpectedly bright. A paper based on observations from STEREO, SOHO, and GOES 1-9 instruments revealed something extraordinary. The brightness rose rapidly. The scaling relationship was -7.5. -7.5. For natural comets, this relationship should be different. Dust scatters sunlight. Red light scatters less efficiently than blue light. A comet should appear redder as it nears the sunday. Warmer dust should emit redder light. But 3I Atlas appeared blue. The surface temperature at perihelion is about 20 times colder than the sun's photosphere. The sun radiates at 5,800 degrees Kelvin. The comet's surface is roughly 300 degrees Kelvin. This temperature difference means red light should dominate, yet the object grew blue. Dr. Loeb identified this as the 9th anomaly. The 9th. There have been 8 others. 8 unexplained properties. 8 departures from natural comet behavior. He listed what would need to be true if 3I Atlas is natural. The blue appearance could indicate ionized carbon monoxide. Possible, but unusual. Unexpected, surprising to researchers. Or it could indicate something else. A hot engine, a source of artificial light, something generating its own radiation. Here is the question you must ask yourself. Is it more likely that 9 independent anomalies occur randomly in a single object, or that something fundamentally different is happening? Thank you for being with us. Please subscribe, share this episode, give us a thumbs up. In the next 30 minutes, you will discover why scientists are divided. Some researchers maintain 3I Atlas is natural. Others are asking questions no one wanted to ask. The European Space Agency confirmed no danger to Earth. The closest approach to our planet occurs on December 19, 269 million kilometers. Safe, distant, but observable. Yet between now and December, something crucial will happen. The ESA's Jupiter Icy Moons Explorer, called JUICE, will observe 3I Atlas. Multiple instruments. The comet is now farther away than during Mars orbiter observations. But JUICE will attempt imaging anyway. Scientists will not receive this data until February. The spacecraft transmission rate is slow, but when the images arrive, they will answer a critical question. Is there a massive gas cloud? If yes, then cometary evaporation explains everything. 9 anomalies become statistical noise, natural complexity. The object is a dirty snowball, ancient, transformed by radiation, but fundamentally a comet. If no, then explanations become scarce. The non-gravitational acceleration remains unexplained. The blue appearance lacks a natural cause. The 9 anomalies cluster together in a way that defies probability. Here is where the timing becomes suspicious. A government shutdown in October prevented NASA data sharing. Images from Mars Reconnaissance Orbiter remained classified by circumstance, not by policy, by accident of government dysfunction. Yet this accident kept critical information from the scientific community for weeks. Why does timing matter? Because Dr. Loeb is watching. The scientific community is watching. Hundreds of telescopes will train on this object in November and December. The Hubble Space Telescope, the James Webb Space Telescope, ground-based observatories worldwide. If a massive gas cloud surrounds 3I Atlas, it will be impossible to hide. The spectroscopy will reveal it. The imaging will show it. The data will be unambiguous. But between now and when that data arrives, the narrative remains open. Think about what this means. A decision point approaches. In weeks, we will know. In December, the comet reaches closest approach to Earth. The observations will be exhaustive. The analysis will be thorough. The answer will be scientific, not speculative, not theoretical, but evidence will dictate the conclusion. Here is what we know for certain today. An acceleration occurred. Calculations demand mass loss or alternative explanation. No gas cloud is visible yet. The object exhibits 9 anomalous properties. The timing of data delays is convenient for mystery. Scientists are not arguing whether 3I Atlas is unusual. They are arguing what that unusual nature means. Some maintain natural explanations suffice. Others wonder if we are witnessing something unprecedented, something our models cannot accommodate, something requiring new understanding of physics or technology. The next 48 days will decide this question. Between now and December 19, we will gather the most comprehensive observational data ever collected on an interstellar object. We will measure, we will analyze, we will attempt understanding. What comes next will reshape astronomy. But first we must wait. We must observe. We must let the data speak without bias or assumption. We must ask hard questions. We must admit uncertainty while pursuing truth. That is where we stand tonight. That is the status of 3I Atlas as October closes and November begins. Tomorrow, the comet will rotate further from the Sunday. The James Webb Space Telescope will gather more spectroscopy. Ground-based telescopes will track its position. Hundreds of researchers in dozens of countries will examine the data. They will debate interpretations. They will propose theories. Some will maintain the natural explanation. Others will push boundaries. Some will suggest possibilities that challenge our frameworks. But all of them will be watching. All of them will be waiting. All of them will understand that something unusual is moving through our solar system, something that demands explanation, something that might teach us something profound about the universe. This is 3I Atlas, the object that appeared in our cosmic neighborhood on July 1 when discovered, the third recognized interstellar visitor to our solar system, the first to exhibit this particular pattern of anomalies, the first to generate this level of scientific division and public curiosity. Yesterday, we ended with a question. Are you ready? Today, we answer it with data, with evidence, with conflicting interpretations that reveal how science actually works when facing the unknown. But first, let us revisit those 33 billion tons. Remember that number from the start? Still cannot get past it. The mass loss required if cometary outgassing caused the acceleration. Dr. Loeb calculated this using fundamental physics. Conservation of momentum, no assumptions, no speculation, pure mathematics applied to observations. Now imagine you are a researcher. You hold this calculation, 33 billion tons in a month. Your colleagues ask one simple question: where is it? The answer matters more than you might think. Here is the problem. The scientific community is divided into two camps. Camp A maintains natural processes, explain everything. Camp B asks whether natural processes are sufficient. Dr. Yanga Fernandez works at Florida Institute of Technology. He is a comet specialist. He has studied dozens of comets. He noted something important. The outgassing rate measured by James Webb does not account for the acceleration. The rate detected is roughly 150 kilograms per second during earlier observations. This measured rate cannot generate the non-gravitational acceleration observed at perihelion. Think through this logic with me. If outgassing at 150 kilograms per second fails to explain the acceleration, then outgassing must have increased dramatically at perihelion. The rate must have accelerated exponentially, or the source of acceleration is not outgassing at all. Fernandez stated that 3I Atlas is the most active comet ever observed relative to its size. But activity alone does not solve the puzzle. The timing is critical. The acceleration appeared specifically at perihelion. Specifically, when the comet reached closest approach to the Sunday, natural heating accelerates at perihelion. Heat does cause more sublimation, more gas ejection, more momentum transfer. This part aligns with natural processes, but the magnitude does not align. Here is where we enter technical territory. This matters because the details reveal the truth. The comet has a nucleus estimated between 3 and 14 kilometers in diameter. Some estimates place it larger, some smaller. This uncertainty itself is telling. We cannot even agree on the basic size of this object from 70 million kilometers away. At perihelion, solar heating reaches maximum intensity. Volatile ices begin to sublimate. Carbon dioxide transitions from solid directly to gas. This process is called sublimation. It happens without liquid phase. The sudden phase change releases energy. Gas accelerates outward from the nucleus. For natural comets, this process is understood, modeled, predicted. For 3I Atlas, the models fail. Dr. Marco Micheli from European Space Agency conducted the original acceleration measurement. He used positional data from multiple telescopes and spacecraft. The Atacama Large Millimeter Array provided millimeter wavelength observations. This is high-precision astronomical data, not speculative, not theoretical, measured. Micheli reported the comet was 4 arcseconds off from predicted position. In astronomy, 4 arcseconds is significant. It represents a measurable deviation that requires explanation. But here is what makes this interesting. Dr. Loeb published a follow-up analysis. He used momentum conservation to reverse engineer what must have happened. If the acceleration came from sublimation, then mass loss rate must be much higher than measured earlier. He calculated that 3I Atlas must have lost 1/6 of its total mass during the months surrounding perihelion. Now, Imagine you are a comet scientist. Your entire career studying these objects. You know what they do. You know how much they can outgas. You know the limits of sublimation under solar heating. Then you receive this calculation: 1/6 of total mass in 1 month. Your first reaction is likely skepticism. Your second reaction is checking the math. Your third reaction is looking for the gas cloud that must accompany this loss. The fourth reaction is concern when you do not find it. Let us talk about what this means observationally. A comet losing significant mass creates signatures. Spectroscopy reveals molecular emissions. Imaging shows dust and gas surrounding the nucleus. The coma expands. It glows. It becomes visible to sensitive instruments. The European Space Agency, NASA, and dozens of other space agencies have instruments dedicated to detecting cometary outgassing. These instruments are extremely sensitive. They can detect minute quantities of molecules. They can measure elemental ratios. They can map gas distributions around the nucleus. If 33 billion tons of material ejected from 3I Atlas, these instruments should detect it conclusively. Yet the detection is ambiguous. Some researchers point to measured emissions as evidence of outgassing. Others note the emissions are far below what 33 billion tons should produce. The discrepancy is not minor. It is substantial, orders of magnitude different. Here is where expert disagreement becomes public. Brian Cox is a science popularizer, physicist. He has written popular books about the universe. He appeared in media interviews advocating strongly for natural explanation. He stated definitively that 3I Atlas is a natural comet. His statements were absolute. No uncertainty, no admission that alternative possibilities exist. Dr. Loeb responded in writing. He noted that Brian Cox had not authored a single scientific paper about 3I Atlas. He was not engaged with the research. He was offering opinion based on intuition and general knowledge of comets. Dr. Loeb was direct. He said, "Scientific truth is not decided by popularity contests. It is decided by attention to data, especially anomalous data." This disagreement matters because it reveals something important about how science actually responds to anomalies. Think about this from a sociological perspective. A famous science communicator takes a strong stance for natural explanation. He has a platform. He has credibility with the public. He reaches millions of people. When he speaks with certainty, people believe him. But his certainty is not based on original research. It is based on assumption that past patterns continue, that new objects behave like old objects, that anomalies dissolve when examined closely. Sometimes this assumption is correct, most of the time actually, but not always. Dr. Loeb represents a different approach. He examines anomalies. He does not dismiss them. He asks what would need to be true if they are genuine. He publishes calculations. He invites peer review. He admits uncertainty while pursuing uncommon possibilities. Here is the key distinction. Cox assumes. Loeb tests. Now, let us examine what historical comparison teaches us. The first interstellar object discovered was 1I Oumuamua, discovered in 2017. It exhibited non-gravitational acceleration. For years, researchers searched for the explanation. Cometary outgassing was suggested, but no gas was detected around Oumuamua. The Spitzer Space Telescope conducted deep observations, sensitive, capable of detecting small quantities of material. Oumuamua showed no visible tail, no obvious coma, no detectable gas around the nucleus. Comet researchers faced a problem. A comet is defined by its tail. The tail is the defining signature. Gas and dust ejected from the nucleus creates the tail. It glows. It becomes visible. Oumuamua had no tail, yet it behaved like an object undergoing acceleration, like an object with a propulsion source, like something being pushed. Comet experts resolved this by creating a new category. They called it a dark comet, a comet without a visible tail, an oxymoron by definition, a comet that does not behave like a comet. Dr. Loeb pointed out the logical problem. He used an analogy. Imagine a cave dweller who has never seen a cell phone. He finds one. He has no reference frame for technology. He might classify it as a rare rock. His classification would be wrong, but his logic would be internally consistent. He is making sense of data within his existing framework. Dark comets are similar. Comet experts had no framework for objects that accelerate without outgassing, so they created a category that preserved their existing understanding. A comet without a tail. Unusual but possible. Until it happens again. Now, 5 years later, 3I Atlas exhibits the same pattern. Acceleration, ambiguous outgassing, insufficient gas cloud, an object that behaves like a dark comet. The probability of two independent objects exhibiting the same set of anomalies by chance is worth calculating. Think about this statistically. How many interstellar objects pass through our solar system per year? Estimates suggest very few, perhaps one every decade or century. The solar system is vast. Interstellar space is vaster. The probability of capture is extraordinarily low. We have captured 3. We know of 2. 2 of them exhibit this acceleration pattern. This is not independent events anymore. This is a pattern. Patterns demand explanation. They demand hypotheses. They demand that we reconsider our assumptions. Here is where it gets interesting again. Dr. Karen Meach is at University of Hawaii. She observed one, Oumuamua. She is one of the leading researchers on interstellar objects. She stated something important. The rarity of these objects means each one teaches us something profound. We cannot dismiss them. We cannot ignore anomalies. She is watching 3I Atlas carefully. She has access to observational data. She is considering the implications. She is not committed to either camp, natural or alternative. She is waiting, watching, letting evidence accumulate. This is how cautious science proceeds. But here is the problem with caution. It allows ambiguity to persist. It allows multiple interpretations to coexist. It prevents definitive conclusions. Some observers criticize this approach. They argue that if evidence supports a hypothesis, scientists should commit to it. They should make a clear statement. They should take a stance. Others defend caution. They argue that premature commitment to any explanation blocks investigation of alternatives. Caution preserves intellectual flexibility. It prevents groupthink. It allows genuine discovery. The tension between these positions defines modern astronomy right now. You might wonder why this matters beyond academic debate. Why care about how scientists interpret data? The answer is simple. How we interpret this data determines what we search for next. It determines which hypotheses we test. It determines what instruments we build. It determines the future of space exploration. If 3I Atlas is a natural comet, then we understand it. We move on. We learn about comet formation in other star systems. We refine our models. This is valuable. This is important science. But if 3I Atlas is something else, if it represents technology, If it represents something we have not encountered before, then everything changes. The implications become civilizational. The search becomes urgent. The stakes become enormous. This is why the scientific disagreement matters so profoundly. Let us examine the observational data more carefully now. The comet is traveling at 134,000 kilometers per hour relative to the Sunday, 134,000. This is extraordinarily fast. Natural comets ejected from other star systems travel at various speeds, but this speed is at the high end of possibilities. The trajectory is unusual, flat, straight, remarkably linear relative to the ecliptic plane. Most long-period comets have orbital inclinations. Their paths tilt relative to the orbital planes of planets. 3I, Atlas, comes straight in, straight through, nearly flat. The probability of a random trajectory being this flat is calculable. It is low, not impossible, but statistically uncommon. The comet's path brings it to closest approach with Earth on December 19, 269 million kilometers. This is roughly 1.8 times the Earth-Sun distance, safely beyond the orbit of any planet. No impact risk, no danger, but it brings the object close enough for excellent observation. Between now and December 19, 17 days remain until the comet becomes visible to ground-based telescopes again. Currently, it is behind the Sun from Earth's perspective. The JUICE spacecraft will attempt observation in November. The data returns in February. This creates a gap, a period of limited observational data, 6 weeks where our ability to track 3I Atlas diminishes significantly. Here is where timing becomes relevant again. If a massive gas cloud surrounds 3I Atlas, it should grow more visible as the comet moves away from the Sunday gas expands. The coma enlarges. The tail develops if sufficient solar wind and photon pressure act on the ejected material. But if no gas cloud exists, if the acceleration came from another source, then we should see continued anomalous behavior, unexpected properties, continued enigma. The November and December observations will answer this decisively. Scientists have scheduled an intensive monitoring campaign. The International Asteroid Warning Network mobilizes from November 27 through January 27, 1 full month of coordinated telescopic observation. Hundreds of ground-based observatories, space-based instruments, spectroscopy teams, imaging specialists, data analysts, all focused on one comet. This level of mobilization typically occurs only for objects with impact risk or extraordinary scientific significance. 3. I-Atlas has triggered both concerns. Impact risk is minimal, but scientific significance is maximal. Dr. Loeb made a bold prediction. He stated that if the massive gas cloud fails to appear by December, then cometary evaporation cannot explain the acceleration. If we observe 3I Atlas closely for 6 weeks and find no massive cloud of gas, then natural processes are insufficient to explain the data. If that happens, he suggested, the technological signature hypothesis becomes more plausible. Think about what this means. A specific, testable prediction, observable, measurable, definitive. This is how science should proceed when facing anomalies. Create predictions, test them. Let observations decide. The comet will make its closest approach to Earth on December 19. This is the optimal observation window. The angle is favorable. The distance is significant, but not extreme. Multiple observatories can point simultaneously. What happens then will redefine our understanding of 3I Atlas. But between now and then, one more observation opportunity arrives. The JUICE spacecraft passes the comet's vicinity in November, early November. The observation window is brief. The comet is farther than it was from Mars. The signal is fainter, but JUICE will attempt imaging using multiple instruments. If successful, these images will provide crucial data. They will show whether outgassing is accelerating, whether the coma is expanding, whether the nucleus is releasing material visibly. The data will arrive in February. But the observation occurs now, in the next few days. Here is what we know will happen between now and February 19, when the comet reaches Earth proximity and JUICE data arrives. Speculation will increase, media coverage will intensify, public interest will rise. The question will become impossible to ignore. The scientific community will divide further. Some researchers will make bold claims supporting natural explanation. Others will suggest alternative possibilities. The disagreement will become visible to the public. Governments might respond. NASA might release previously withheld data. The Mars Reconnaissance Orbiter images might finally see public distribution. If they contain surprising information, this information will reshape the narrative. The comet will continue on its trajectory, moving away from the Sunday, moving toward Earth, becoming visible to naked eye telescopes in mid-November, remaining visible through December. During this time, every observation will be crucial. Every image will be analyzed. Every spectrum will be examined for anomalies. And underneath all of this, one fundamental question persists. Is 3I Atlas an ancient, radiation-damaged comet following natural physical laws? Or is it something else entirely? The answer approaches, but we do not have it yet. If you are just joining us, let me explain what has happened over the past 70 minutes. An interstellar comet called 3I Atlas arrived at closest approach to our Sun on October 29. It exhibited acceleration that gravity cannot explain. Scientists divided into two camps. One camp says natural processes explain everything. The other asks whether natural processes are sufficient. Today, we examine why this question matters beyond astronomy. Let us begin with stakes. What happens if we answer this question wrong? Here is the problem. Our civilization has built technology into near-Earth space. Satellites, space stations, telescopes. We have assumed we understood the cosmos. We assumed the laws of physics that govern Earth also govern distant stars. We assumed that objects moving through space obey predictable rules. What if that assumption is incomplete? Think about this. Throughout history, when humans discovered something unexpected, the initial response was denial. The first reports of meteorites falling from the sky were dismissed. Rocks from space? Impossible. Gravity holds everything. Yet meteorites were real. They taught us about planetary formation. We discovered gravitational waves less than 15 years ago. Einstein predicted them in 1916. We confirmed them in 2015. That is nearly a century of the scientific community saying, these waves probably exist, but we cannot measure them. Then suddenly, we could. We built sensitive enough instruments. Reality confirmed prediction. What if 3I Atlas is similar? What if we are observing something real that our existing frameworks cannot accommodate? Dr. Thomas Zurbuchen is chief scientist at NASA. He made a statement that deserves attention. He noted that the discovery of interstellar objects has only recently become possible. Our telescope technology only recently became sensitive enough. We have observed exactly 3 interstellar objects. 3. 2 of them exhibit anomalous acceleration. 2 of 3. This is not noise, this is pattern. Zurbuchen stated that we should remain open to multiple hypotheses. We should not commit prematurely to any explanation. We should let evidence accumulate and guide interpretation. This is cautious science speaking. But caution has costs. The costs include sustained uncertainty. They include public confusion. They include missed opportunities if we are too slow to recognize something genuinely new. Here's where public perception becomes relevant. Social media erupted in discussion when the acceleration data was released. Online communities speculated. The term technological signature trended on platforms. Millions of people discussed whether 3I Atlas might represent extraterrestrial technology. Governments noticed. The United States Congress requested briefings on 3I Atlas. Representative Anna Paulina Luna wrote to NASA Administrator Sean Duffy. She questioned why data was being withheld due to government shutdown. She advocated for rapid data release. She brought political pressure to bear on what was supposedly a technical issue. Why? Because the public was asking questions. The public understood that something unusual was occurring. The public wanted answers. This forced scientific institutions to respond. NASA released statements about 3I Atlas. The European Space Agency issued clarifications. Organizations that typically avoid public statements issued formal communications about an interstellar comet. Something shifted. The conversation moved from academic journals to news media to public discourse. Conspiracy theories multiplied. This was inevitable. When authorities are vague, when experts disagree, when data is ambiguous, people fill the gaps with speculation. Some speculation is reasonable. Some is unreasonable. The internet makes no distinction. One claim circulated widely. Government agencies knew the truth about 3I Atlas, but were concealing it. The evidence offered was circumstantial. The government shutdown timing, the data release delays, the lack of definitive statements from authorities. Dr. Loeb addressed this directly. He said if governments possessed evidence of extraterrestrial technology, they would be unable to conceal it. Too many independent observers, too many space agencies, too many countries. A true discovery would leak immediately. The Chinese would announce it, the Europeans would announce it, Russia would announce it. Governments cannot keep secrets when multiple organizations independently observe the same phenomena. The incentive to be first would override the desire for secrecy. This reasoning is sound, but it does not calm public anxiety. It does not resolve public curiosity. It does not answer the fundamental question, what is 3I Atlas? Here is what matters most about public perception. If 3I Atlas eventually proves to be something genuinely unusual, something truly anomalous, then the public was right to be curious. The public was right to ask questions. The public was right to pressure for data release and transparency. But if 3I Atlas proves to be a natural comet, then the public worry was misdirected. The speculation was noise. The theories were false. Either way, public engagement with this question is healthy. It reflects genuine interest in understanding the cosmos. It reflects the desire to know truth. It reflects humanity's curiosity about our place in the universe. Now, let us examine limitations. What can we not measure? What remains hidden? Here is the fundamental constraint. We are observing from Earth and from spacecraft in our solar system. We are looking at 3I Atlas from extremely far away. The closest point of approach to our planet is still 269 million kilometers. This is a vast distance. Our best telescopes can resolve details down to roughly 1 kilometer at this distance. The nucleus of 3I Atlas is perhaps 3 to 14 kilometers in diameter. so we can barely resolve the nucleus itself. We cannot see surface features. We cannot directly observe outgassing. We cannot measure temperatures at the nucleus. We can measure indirect signatures. We can detect molecular emissions. We can measure brightness changes. We can track position changes. But we cannot directly observe the surface of this object. This limitation is fundamental. It cannot be overcome without sending a spacecraft to intercept 3I Atlas. And 3I Atlas is moving at 134,000 kilometers per hour. Catching it would require advanced propulsion. We do not possess this technology currently, so we must rely on remote observation. We must infer internal properties from external signatures. We must make assumptions about composition based on spectroscopy. Here is another limitation. Our instruments were designed for objects in our solar system: asteroids, comets, planets. We had never expected to observe interstellar objects so closely. Our instruments were not optimized for this. When the ExoMars Trace Gas Orbiter attempted imaging of 3I Atlas, the success was marginal. The cameras are designed to analyze Martian surface. They are not designed for faint objects in space. The comet appeared as a faint white dot, barely visible, challenging to interpret. Yet, this marginal success provided critical data. It proved that Mars orbiters could detect the comet. It provided positional data. It contributed to the acceleration measurements that revealed the anomaly. But imagine if we had better instruments. Imagine if we had telescopes optimized specifically for interstellar object observation. Imagine what we might see. This is where future missions become relevant. Dr. Loeb has proposed that humanity should prioritize interstellar object study. We should design missions specifically to intercept and study these objects. We should develop technology to match their velocity. We should send spacecraft capable of imaging the nucleus in detail. This would cost billions. It would require international cooperation. It would need political will. But it would answer questions definitively. No more ambiguity, no more debate. Direct observation would settle every question. The scientific community is divided on this priority. Some argue that a mission to 3I Atlas would be premature. We should study more interstellar objects first. We should develop better understanding before committing massive resources. Others argue that missions should begin now. Every year of delay means 3I Atlas moves farther away. Eventually, it will become impossible to reach. Eventually, the opportunity will pass. This disagreement reflects genuine tension in scientific prioritization. Resources are limited. Choices must be made. Not all worthy projects can proceed simultaneously. Here is another limitation worth considering. Time. 3I Atlas will not remain in our solar system forever. Its trajectory brings it through perihelion. It approaches Earth in December. Then it begins its departure. By late 2026 or early 2027, it will exit our solar system. It will return to interstellar space. We have months, not years. Months to gather all possible data. Months to observe from all angles. Months to measure every possible property. After that, 3I Atlas is beyond our reach. Its story becomes sealed. Whatever it is, whatever it means, we will have only our December observations to base future understanding on. This creates urgency, genuine urgency. The window is closing. Astronomers worldwide understand this. They are prioritizing 3I Atlas. They are scheduling observing time at the most sensitive telescopes. They are coordinating international efforts. They are preparing for the most intensive study of a single comet in history. But time limitations mean some questions will go unanswered, some properties will remain unmeasured, some mysteries will persist even after careful observation. We will know more in December. But we may not know everything. Here is where anticipation becomes powerful. Think about the scenario. December 19 approaches. The comet reaches closest point to Earth. Multiple space telescopes point at it simultaneously. Ground-based observatories train their instruments on it. Spectroscopy teams analyze light signatures. Imaging specialists study photographs. The data flows in. Raw observations, initial analysis, preliminary conclusions. Scientists gather in virtual conferences. They debate interpretation. They argue about meaning. They propose hypotheses. They test each other's logic. The world watches. Social media erupts again, but this time with data to ground speculation. This time with measurements to reference. This time with actual information instead of pure theory. The answer emerges, gradually at first, tentatively, then with increasing certainty. Is 3I Atlas natural or anomalous? Here is what we know must happen. If the gas cloud appears, if we measure massive outgassing, if the spectroscopy shows carbon dioxide, carbon monoxide, water vapor in quantities consistent with 33 billion tons, then natural explanation prevails. The acceleration is explained. The anomalies resolve into normal complexity. The mystery ends. If the gas cloud does not appear, if our measurements find no massive plume, if spectroscopy shows insufficient material ejection, then we have a genuine scientific enigma, something we cannot explain with existing frameworks. In that scenario, research becomes urgent. Universities propose programs, conferences schedule sessions. Research teams compete to explain the anomaly. Some will propose modifications to natural comet models. Perhaps something about interstellar conditions makes outgassing more efficient. Perhaps 3I Atlas contains material we have never encountered before. Perhaps our assumptions about sublimation are incomplete. Others will propose less conventional hypotheses. Perhaps the object is technological. Perhaps it represents something we have not encountered in our solar system. The debate will be intense. The stakes will be high. The implications will extend far beyond astronomy. But underneath all this discussion, one certainty will persist. We will have data. We will have measurements. We will have evidence. The speculation will be grounded in observation. The debate will concern interpretation of facts, not generation of facts. This is how science should proceed. You have been with us for 70 minutes now. We have covered vast territory. We have examined the acceleration anomaly. We have explored the radiation aging of the nucleus. We have discussed the mysterious blue appearance. We have considered expert disagreement. We have analyzed public response, but we have not answered the central question. Is 3I Atlas a comet or something else? Here is the honest answer. We do not know. We will not know until December. We have compelling evidence on both sides. We have natural explanations that work partially. We have anomalies that resist easy explanation. We have expert consensus that breaks down when examined carefully. This uncertainty is uncomfortable. Humans prefer definitive answers. We prefer to know. We prefer certainty. But sometimes science proceeds through uncertainty. Sometimes discovery requires living with ambiguity. Sometimes the most important observations are those that force us to reconsider our assumptions. 3. Atlas is forcing reconsideration. It is demanding that we look more carefully at interstellar objects. It is pushing us to develop better instruments. It is prompting new missions. It is stimulating research into areas previously considered settled. This is how paradigm shifts occur, not through sudden revelation, but through accumulating anomalies that existing frameworks cannot contain. Max Planck famously noted that science progresses funeral by funeral. Each generation of scientists must be convinced by evidence. The previous generation must retire. New thinking must emerge. 3I Atlas might represent one of those generational transitions, a moment where anomalies become undeniable, where new frameworks become necessary. Or it might be a complex comet, an ancient object shaped by billions of years of radiation, unusual but natural, exceptional but explicable. Between now and December, we gather data, we measure, we observe, we accumulate evidence, we prepare for either scenario. Here is what happens next. In November, telescopes begin daily observations. The comet emerges from behind the Sunday faint at first, then growing brighter. Ground-based observatories detect it. Professional astronomers coordinate. Amateur astronomers contribute. Science becomes a collective effort. The JUICE spacecraft attempts observation in early November. The data arrives in February, but the observation occurs in the darkness of space. A spacecraft alone with an ancient object arriving from another star system. Between November 11 and December 19, thousands of observations accumulate, millions of data points, terabytes of information. The complete picture of 3I Atlas emerges gradually. Properties reveal themselves. Mysteries persist. Some answers appear. December 19 arrives. The comet reaches closest approach to Earth. The observational opportunity peaks. The most intensive study occurs. The best data flows in. Then the analysis phase begins. Scientists examine everything. They debate interpretation. They propose models. They test hypotheses against evidence. By late December or early January, preliminary conclusions emerge. By February, more comprehensive analysis completes. By spring 2026, the scientific community has reached consensus or acknowledged genuine disagreement. But the question will be answered, or the disagreement will be understood well enough to guide future research. This is the arc of discovery. This is how science progresses when facing genuine novelty. You have been part of this journey with us. You have considered evidence. You have examined anomalies. You have thought about implications. You have engaged with the question seriously. In the next phase, the answer approaches. The observation window opens. The data flows in. The community responds. This is where 3I Atlas becomes more than an astronomical curiosity. This is where it becomes a test of how humanity responds to genuine uncertainty, how we gather evidence, how we interpret data, how we reach toward truth. We stand at a threshold. Behind us lie 3 hours of investigation. Ahead lies a question that might reshape our understanding of the universe. Between now and that answer, the cosmos continues its indifferent motion. But human attention focuses here, on this comet, on this object, on this problem that refuses easy solution. Let me take you somewhere unexpected. Let me show you why this matters beyond astronomy. Imagine you are part of a civilization that believes it understands its place in the universe. You have mapped the solar system. You have categorized comets. You have built telescopes that can see across billions of years. You have confidence in your knowledge. Then something arrives that does not fit your categories. Something that exhibits properties you have never observed. Something that forces you to admit uncertainty. What does that moment mean? Throughout human history, Moments like this have redefined civilization. Copernicus challenged the geocentric model. His calculations showed the Earth orbits the Sunday. The response was denial, resistance, eventually acceptance, eventually revolution in human thought. Darwin presented evidence that humans evolved from earlier species. The response was outrage, denial, eventually acceptance, eventually transformation in human self-understanding. Einstein showed that space and time are flexible, not absolute. The response was confusion, disbelief, eventually acceptance, eventually relativity, as foundation of modern physics. Each time, something we thought we understood turned out to be incomplete. Each time, new understanding required abandoning comfortable assumptions. Each time, discovery came through confronting anomalies rather than dismissing them. 3I Atlas might be similar, or it might be a complex comet. Either way, the moment we confront it is significant. Here is why this matters personally to you. The question is not academic. It is existential. If 3I Atlas represents technology from another civilization, then we are not alone. We have never been alone. Beings elsewhere in the cosmos possess capabilities we have not yet developed. They have traveled between stars. They have moved through interstellar space. They have arrived at our Sunday. What does that mean for humanity? It means our technological trajectory might not be unique. Other paths exist. Other solutions to the problem of interstellar travel have been found. Other civilizations have achieved what we have not yet achieved. It means we are younger, less advanced, further behind in the cosmic developmental sequence. It means we have much to learn. This prospect frightens some. It thrills others. It humbles everyone who contemplates it seriously. But consider the alternative. If 3I Atlas is a natural comet, then we live in a cosmos governed by physics we understand. Comets form in other star systems, just as they form in ours. Objects move through space following natural laws. We are alone, at least in our immediate cosmic neighborhood. No visitors arrive from distant stars. No technology challenges our understanding. This is comfortable. It is familiar. It preserves our sense of normalcy. It suggests we have grasped the essential nature of reality. But it also suggests something depressing. It suggests that the appearance of technological signatures might be unlikely. It suggests that civilizations capable of interstellar travel might be extraordinarily rare. It suggests we might be truly alone in ways that amplify our isolation. Between these two futures, which matters more? Which would you rather be true? The honest answer is that what matters is truth. Not comfort, not fear, not hope. Truth. 3I Atlas will tell us something. Either it will confirm that natural processes dominate the cosmos, or it will suggest that something else is possible. Either answer is scientifically valuable. Either answer teaches us something profound. Dr. Avi Loeb has said something important about this moment. He said that science should follow evidence, not intuition, should follow data, not comfort, should confront anomalies rather than dismiss them. This is courageous science. This is science that risks being wrong. Science that risks ridicule if the hypothesis proves false. Science that accepts the possibility of failure in pursuit of truth. This is also the only science that leads to genuine discovery. Compare this to the easy path, the path Brian Cox took. Announce confidently that 3I Atlas is natural. Explain the anomalies away. Preserve the existing framework. receive no criticism because you have committed to the expected answer. One approach is safe. One is brave. Only one can be right. And rightness will be determined by December data. Here is what we can say with certainty today. 3I Atlas exhibits acceleration that gravity alone cannot explain. This is measured fact. This is not speculation. This is what the data shows. 3I Atlas exhibits unusually bright appearance. This is measured fact. This is confirmed by spectroscopic data. 3I Atlas appears blue when it should appear red. This is observed. This is unusual. This violates initial expectations. 3I Atlas released carbon dioxide in quantities suggesting radiation processing over billions of years. This is confirmed by James Webb observations. 3I Atlas has no visible tail. This is observed. This is consistent with previous interstellar object. These facts are secure. They are not debated. They form the foundation of all interpretation. Everything else is interpretation. How we explain these facts, what they mean, what implications follow. The December observations will provide additional facts, new measurements, fresh data. The interpretation will then refine. The certainty will increase. The answer will emerge. But between now and December, ambiguity persists. Multiple explanations remain possible. Expert disagreement continues. Public speculation multiplies. This is the space between observation and understanding. This is where science lives when confronting genuine novelty. How long does this space persist? Typically, months or years. Extraordinary objects require time for systematic study, time for multiple observations, time for peer review, time for alternative hypotheses to be tested and eliminated or confirmed. 3I Atlas compresses this timeline. The object moves quickly. Our observation window is limited. We have months, not years, to gather decisive data. This compression creates urgency, but it also creates risk. Risk that we will commit prematurely to incomplete understanding. Risk that we will dismiss genuine anomalies before studying them thoroughly. Risk that we will miss the true story because we move too quickly. Scientists understand this risk. They are attempting to balance urgency with rigor. They want answers quickly, but they want those answers to be correct. This balance is difficult to maintain. It creates tension, pressure, disagreement about how to proceed. But it is necessary tension. It prevents hasty conclusions. It preserves scientific integrity. Here is what we know about the next weeks. November 11 marks the date when ground-based telescopes should first detect 3I Atlas after solar conjunction. The comet emerges from behind the sun and becomes visible to Earth-based observers. The daily observation campaign begins. Between November 11 and November 27, preliminary data accumulates, brightness measurements, spectroscopic observations, positional tracking, the preliminary picture of how the comet has changed since perihelion begins to emerge. November 27 marks the beginning of the International Asteroid Warning Network campaign. Coordinated observations from hundreds of telescopes. Multiple teams analyzing the same object simultaneously. Systematic gathering of comprehensive data. This campaign runs through the 27th of January 2026. 2 months of intensive observation, 2 months of coordinated effort, 2 months of data accumulation. December 19 represents the peak, closest approach to Earth, the most favorable observation geometry, the optimal moment for all telescopes to gather their best data. What happens if observers detect a massive gas cloud? The data becomes consistent with natural explanation. The outgassing rate must have increased dramatically at perihelion. The acceleration came from a cometary rocket effect. The anomalies become less mysterious. The object fits established comet categories. This scenario ends the story. 3. I-Atlas becomes a complex comet, important scientifically, but explainable within existing frameworks. New understanding becomes refinement of existing understanding. No paradigm shift required. What happens if observers detect no massive gas cloud? Then we have genuine enigma. The acceleration cannot be explained by documented outgassing. The object must be explained by some other mechanism. The anomalies cluster. The coincidences mount. The case for alternative hypothesis strengthens. In this scenario, the scientific debate intensifies. Competing hypotheses become serious. Alternative mechanisms gain credibility. The community divides further. The question becomes urgent for funding agencies and political leaders. One scenario leads to closure. One leads to opening of new questions. One answers the mystery. One deepens it. Which will December bring? We do not know. Here's what we can control. We can commit to watching closely. We can commit to following evidence. We can commit to resisting the temptation to explain too quickly. We can commit to confronting anomalies rather than dismissing them. We can commit to truth-seeking over comfort-seeking. This is the Challenge 3 I-Atlas presents, not just as astronomical object, but as ethical challenge, as challenge to how we pursue understanding, as challenge to maintain intellectual honesty when easier paths exist. Some will take the easy path. They will declare 3, I-Atlas natural, and move on. This is likely. This is often what happens. Anomalies get explained away. Disruption gets avoided. The existing order persists. Others will maintain open-minded skepticism. They will gather data methodically. They will test hypotheses rigorously. They will admit uncertainty. They will follow evidence wherever it leads. Both approaches are represented in the scientific community. Both reflect genuine commitment to science, but they differ in what they prioritize: safety or discovery, certainty or honesty, comfort or truth. You, watching this episode, are part of this story. Your curiosity brought you here. Your willingness to consider multiple possibilities brought you to this moment. Your desire to understand the universe brought you to 3, I-Atlas. This matters more than you might realize. Public interest drives funding. Funding drives research. Research drives discovery. Your attention, your engagement, your questions matter because they create pressure on institutions to pursue understanding rather than comfort. When millions of people care about an answer, institutions respond. They commit resources. They prioritize investigation. They pursue truth because avoiding truth becomes politically difficult. The 3, I-Atlas, reached our solar system by chance or by design if alternative hypothesis proves correct. Either way, its arrival created an opportunity to look closely at something genuinely unusual, an opportunity to confront anomalies, an opportunity to ask whether our understanding is complete. December will bring answers. Or more precisely, December will bring data that informs answers. The data will not resolve everything. Ambiguity will likely persist. Expert disagreement will continue. But the data will constrain possibilities. It will eliminate some hypotheses. It will support others. It will move us closer to understanding. This is how science actually works. Not through dramatic breakthroughs, through gradual accumulation of evidence, through careful analysis, through disciplined reasoning applied to observed facts. 3. iAtlas is following this process. We are following it alongside millions of others. December approaches. The observation window opens. The data flows in. The story continues. Here is what we know for certain. 33 billion tons. Remember that number from the very beginning? The mass loss required if cometary outgassing caused the acceleration. That number is the key to everything. If that mass appears as observable gas cloud, natural explanation prevails. If it does not appear, everything changes. Between now and December 19, we will learn whether those 33 billion tons exist. We will learn whether the comet released them. We will learn whether they are visible. We will learn what they mean. This single number becomes the dividing point, the measurement that determines interpretation, the data point that decides between frameworks. 3 words, 33 billion tons. 3 words that might reshape human understanding of the cosmos. Between now and December, watch, listen, think, engage with the question. Do not accept easy answers. Do not dismiss anomalies. Do not prefer comfort to truth. Follow the evidence. Support those following evidence. Contribute to the collective effort to understand. December brings answers, or the beginning of answers, or the framework within which better questions can be asked. Either way, a threshold approaches. A moment when human understanding either expands or consolidates. A moment when the cosmos either confirms our models or surprises us. 3. iAtlas waits. It continues its trajectory. It moves toward Earth. It approaches the moment of ultimate scrutiny. And we prepare. We gather instruments. We coordinate telescopes. We ready ourselves to see what this ancient object has to teach. We prepare to confront whatever truth emerges from December's observations. The next chapter of discovery begins in November. The climax arrives in December. The resolution unfolds through the winter of 2025 and spring of 2026. But the story is happening now. It is unfolding today. It is occurring in real time as you listen, as 3iAtlas moves through our solar system, as scientists prepare observations, as the world watches and waits. You are part of this. Your engagement is part of this. Your willingness to think seriously about these questions is part of the collective human effort to understand the universe. That matters. That means something. That contributes to the discovery process that will define the next phase of human understanding. 3. iAtlas arrived from beyond. It may have arrived as Comet, it may have arrived as something else, but it has arrived. It has forced questions. It has demanded investigation. December will provide answers. Until then, we watch, we wait, we remain open to what discovery brings. Thank you for being with us. Please subscribe, share this episode.